Hello, thank you for watching my project. This is going to be the scientific calculator we make in CS3A. So we're going to start the program. We're going to first input an expression 3 times 3 minus 5 plus 8 times 2. The answer should be 20. This is a great equation to test your precedence because what happens is the minus and the plus, when they should be evaluated accordingly, not that it should be stacked on top of each other in your stack. So let's just try another equation. This is 3 times x plus 5. This is one of my error checks. So what happens is I said without a variable, and when it gets pushed into the stack, it sees that, hey, this is a variable. Alright, I'm gonna throw it, and it's gonna give me this error. So now we're going into the polynomial. We're going to do the quadratic, x squared plus 4x plus 4. And we're going to do the domain as negative 20 to 20. The increment is 1. I use SVG. SVG was a easy way to graph, and it compared to your SFML counterpart people. But anyways, what happens is there's a issue with SVG where if your increment is too large, it will look choppy, because what happens is Polyline, the way it works is that it plots points and connects them. So if your increment is too wide, you'll get very rigid lines. So we're going to do sine x plus 5, showing this, and we're going to do the domain as negative 20 to 20. The sine graph 1 will be the larger increment, whereas sine graph 2 will be the small increment, and the sine graph 2 should actually be a very smooth line. Going into our build, that is where our file is stored. This is the quadratic. You see how it's a beautiful curve. Looks very nice. The outside is preset. The axes are also preset. It will look the same throughout all graphs you will make. You see here that there's a little bit of a rigidness at the bottom. It's because how Polyline, like I said earlier, Polyline, I give it points and it will connect the dots for me. We can see the code here. I'm going to open it with Notepad. All of this is preset. This is the purple line, the graph. And this is the bottom part is also preset. The only difference is the points after the polyline points equals. You see how they're big numbers? The one is negative 4,610. What happens is the problem with SVG is that the origin is actually at the top corner. I'll show you here. Yeah, it's right there at the top corner. And what I had to do was actually center it. This is a 500 by 500, so I had to actually add 250 to center it to both x and y, and then I also had to flip y, because actually when it graphs, it goes downward. So what I had to do is I had to flip it. So I had to make those negative numbers. That's why you saw the negative 4,610, right? Anyway, so this is our sine graph. You see how choppy it is, right? This is a large increment. I will show you the other graph. Like I said, this is how Polyline works. You see here, this is a very smooth line. This is how sine graph should look. So basically, make your increment small, and you'll be able to see that your graph is working correctly. So back to our code. I'm going to just briefly explain this. Token is our parent. It has a children, left paren, number, operators, right paren, and variable. And what we use in our calculator is how we store our different objects like numbers and operators and left paren is by calling them token pointers. You know, we have a queue of token pointers and we have a stack of token pointers. This is how we're able to store varying objects. And you see here, this is our tokenizer. We're going to tokenize every part, and then this is, you see here, you see that if it's a digit, it will make a token pointer of number. So this is, I'm going to just show you a more visual. We're going to use the expression 3 times x plus 5. I forgot the multiply between the 3 and the x. So below that is the postfix Q. this is token pointers, right? So 3 times x plus and then 5. So I've tokened it correctly. I pushed it into the queue. Then it goes into the shunting yard. If it's a number, it gets, this is like our switch statement. If it's a number, we're going to say, oh, push it into the queue. If it's an operator, push it into the stack. And variables we treat as numbers, so it's going to be pushed straight into the queue. And then we have the plus. So what happens is when we have plus, there's a precedence. Caret is the highest precedence, which is like exponents. Multiply, divide is second. Plus, minus is third. And we have left paren as last. And right paren it's different because once right paren is hit, it just pops everything until it hits the left paren. But anyways, so now that the plus is hit, you see below that is the correct postfix expression. It's 3x, and then when plus is hit, multiply gets popped out and put into the postfix expression, like into the queue, and then plus gets pushed into the stack, and then 5 is pushed into the queue, and then plus, now since there's no more in the expression, we say pop what's left in the stack and it gets placed. And so I circled what the postfix expression should be. So like I said, this is a postfix. We're using stack token pointers and token pointer queue. And so now we're here in evaluate. So evaluate, what it does is it takes the numbers and it pushes it into the number stack. And when it hits the operator, it pops the top two, the top most being the right side and the second being the left, and then it operates. So this is my point class. When approaching the variable, when it is a variable, instead of the variable being pushed into the stack, a number in your evaluate parameter will be pushed instead. So now you just have numbers, you pop evaluate with the operator, push that back into stack, same thing. Now your point class takes that number in your parameter and your final answer is the y.